3 coplanar points, and bam, there's the radius of the Earth.
On the level.
The way I phrase it is a monument to the curvature of the Earth. It really
totally
is.
agree with
Level.
It really
totally
is.
agree with
Level.
And bam, there's the radius of the Earth.
You cannot measure an angle with that device.
Yes, you can.
Right, okay.
I just did it. That's what that picture is.
That's a picture of you doing what?
That picture is me measuring an angle below horizontal with an auto level, not a theodolite.
Okay, yes, fair enough. No, there's
Zooming
no zoom.
doesn't change that there's 10 milliradians.
There is no zoom on an auto level.
Yes, there is.
Pardon?
Did you see the email I posted in the debate?
Let's have a look. Yeah.
Cool. What do you think you'll come back with?
Well, it's that is already built into the optics of the thing, right? So
How is it built into the optics? Is it because it's 10 milliradians apart?
it's built in by the guy that puts it in.
Yeah, how?
Because it's individual to each auto level needs its
Because
own
it's-
one of
because
these
it's 10
things that they
milliradians
put
apart.
in there, right? But
What do you think you'll come back with?
all you can do with it is either tell a relationship between the distance and the size of an object. So if you know the distance, you can estimate the size, and if you know the size
How?
of the distance of the object in the Stadia hairs, you can estimate the distance. I mean, that's what
how
they're
does
there
that
for.
relationship work? How does that relationship work? Mathematically,
Exactly
how
what
does it work?
I've just shown you. It's
Muting that guy.
it's
There you go.
it works because it's a function of similar triangles.
Yeah, with a known angle. Have you worked out the
It's an
trigonometry challenge yet?
isosceles triangle.
Yeah, have you worked out the challenge yet?
It's an isosceles triangle, right?
Yeah, with sides 100.
Yeah.
Well, if we do half the isosceles, so we've got a right angle, right? So we'll do one side is 100 and the other side is 1.
1.
Or you can do like the center line of the isosceles as 100 and then the base of it is 2 and
Ooh,
get the
2.
double the angle, whatever.
2. So that would be right. So yeah.
Well, when you said isosceles, right?
Yeah.
The small angle that we're looking at, what's the small angle if you're doing an isosceles with a base of 2?
No, I was saying, as you look through the Stadia hairs, there is a line of similar triangles, right? Yeah?
Right.
Similar
Yes.
isosceles triangles.
Yes.
Well, that's how Stadia hairs. You asked me how to describe mathematically how it works. Yeah, that's what I was doing. I was saying isosceles triangles.
Okay,
Right?
so
Similar
we'll do an isosceles triangle.
triangles. No. Don't say we will do. You asked me to explain how Stadia hairs work mathematically, right? I said to you, it's through isosceles triangles, similar isosceles triangles. That's how they work, right? It was an explanation. I don't know, what are you talking about now? You're on about your trigonometry question now. Did you think that...
Can you do the trigonometry? Why is that similar triangle working? Why is it 100 to 1? And what angle does that give you?
It's probably within Euclidean geometry, right? I bet it's one of the propositions, you know. I bet it's pretty early on.
This is the relationship
Might even be
between
something
angular
like
size, distance, and actual size.
Bridge of Asses or something like that, about number 5, possibly.
I think you're just talking gibberish now. Do you want to do this with an isosceles
Sorry,
triangle or just a right angle triangle?
You're talking gibberish.
You're deflecting. Do you want
No, I
to
was
do the trig on a?
me have a
Let's do it on the right angle triangle. So half
Oh,
the.
you're doing it now? Oh, go on then. Go
I
on,
know
get
what the
on-
answer is.
Get on your live screen and show us all.
Has he got his little baby whiteboard
Yeah, go
going
on.
on there?
Do that.
And you went quiet. What was that?
I said, are you getting your little whiteboard out, showing us?
I'm going to do the trig for you. You're saying you can't do it?
No, I was asking if you wanted to do it.
Can't your
Look at that.
your microphone's going to shit again.
He's on his whiteboard. Leave him alone. For fuck's sake, Roohif.
Hey, can I say hi yet?
Who's
Is
that?
that-
Hey, Rob.
Hey, Rob.
Hey,
How
Rob.
you doing?
Evening, Rob.
Oh, you're back.
Merry Christmas, everybody. Glad to be
Merry
back.
Christmas, Rob.
Hey, Rob.
He's working.
Hey, Rob, I sent the big Gambino a DM for you to debate with him, but he ran away. He didn't answer.
Yeah, I know.
So,
Yeah. I'm
I
trying
don't know
to
what
set
he's
something up this coming Sunday.
this coming
Yeah, you got
Sunday,
a shitload of background noise.
do you want to do it on
Yeah, I got a
Potato's
motorcycle.
channel?
Well, God, I'll be back.
All right, okay.
All right, yeah.
I'll be
Catch you
listening.
later, Rob.
I'll be
In
listening.
a bit.
Muted by the Australian Dum Dum.
Yeah, you know, do you know the Bridge of Asses, Roohif?
No, I want to know whether you can do the trig, Bev.
Did you not get that far?
I've never read Euclid, no.
Okay.
Can you do the trig?
You don't.
Or do I need
you don't,
to do it for you?
You don't read it. You
What do
sort
you need
of
to do the trig for?
practice it.
Work
Well,
through it.
Bev's saying that he understands this relationship, the 100-to-1 relationship inside an auto level.
No,
But
I was.
when-
You asked me if I could explain it mathematically, and I said yeah. It probably
Okay, explain it
something to
mathematically.
do with similar isosceles triangles. I said it's
Something to do
probably.
with.
Yeah, I said it's probably something like what was it?
Probably
Proposition
something.
5, the Bridge of Asses.
Probably something.
Yeah.
Show me mathematically where the 100-to-1 comes from.
It just so happens that Proposition 5 is a theorem within Euclidean geometries, commonly known as the bridge.
Does it explain the 100-to-1
Commonly
in the auto level?
known as the Bridge of Asses.
Does it explain the 100-to-1
The
in the
angles
auto
of
level?
the
Just
base
shut
of an
the
isosceles
fuck up,
triangle
Roohif.
are equal to one another. If their equal sides be produced, the angles of the other side of the base shall be equal to one another.
And what is the small angle?
triangles?
What is the small angle if the base of the isosceles triangle is 1 and the vertical height, so like bisecting the isosceles, if that's 100, what is the small angle in the middle?
What would that be in the equation? Let's see. D, E, no, I, F. No? Distance. It's just got distances and the eyepieces and the focal length.
We're not talking about an auto level. We're just doing geometry here, Bev.
The stadia intercept, the distance from the instrument operator's eye to the stadia reticle eyepiece, focal length.
We're
the
just
distance
doing trigonometry
from the
here, Bev.
instrumenter's eye. No, you're doing trigonometry. We're talking about the stadia hairs of an eyepiece.
Yeah, why are they 100-to-1?
Because
It's
that's
not
the
magic,
way.
Bev. It's not every
that's-
explanation you've given me so
that's-
far has just been it's fucking magic.
That's the way. No, I haven't mentioned anything about magic.
So you know.
Brian, do I know why they're 100-to-1? Yes, because there is 10 milliradians between the stadia hairs.
Why the fuck you asking Bev then?
Yeah.
Bev says you can't measure an angle.
You can't with an auto level.
Measure an angle. It's an auto level.
Yeah, and what's the angular distance between the stadia hairs?
Clue is
Why
a
do
name. Fuck.
Angle.
Say again? Your mic shit, Rob.
Why do you need the angle?
I showed Bev a picture taken through an auto
No,
level to
I-
measure.
No, you're missing the point. Why do you need the angle?
I started explaining and then you interrupted. I showed Bev a picture of me measuring the angle to the horizon using an auto level.
That's not
Bev
what you
said-
do with the tool. No, stop, Roohif. That's not what the tool does. You
It
aim
can
it
measure
at a
an
measuring
angle.
spot, not
It can
27
measure an
kilometers
angle.
away. No, that's not what the tool is designed to do, Roohif, and you know it.
It can measure an angle.
It can't.
So I used it to measure an angle.
Do you want to have a look
To
in
a-
the
to a
debate
measuring rod?
discussion there, Roohif?
No, I just have a measured angle.
You're
Can you ask him
clearly
if he's?
not.
Can you
You're
ask him if he's
clearly
unmuted me,
clowning.
Bev?
Clearly what?
Have you unmuted DP yet, Roohif?
No.
No.
He still talks shit, so.
It sounds like you're the one talking shit, trying to use an auto level to sight a horizon 26 kilometers away. That's
Who
retarded.
cares how far away it is? It doesn't matter how far away it is. I'm just measuring an angle.
The clue is in the
does
name.
Dude, you
Also,
cannot measure an angle, and you're saying who cares how far away it is, whilst trying to use the fucking hairs that give you a distance. You're crazy.
I don't know the height.
You're absolutely fucking mental.
I don't know the height or the distance.
I
I'm just measuring an
know,
angle.
but that's what the Stadia hairs are there for.
No, they measure
They
an angle.
don't
That's how
measure
they work.
fucking angles.
What is the angular distance between the Stadia hairs? What do you think this Civil Today guy is going to come back with, Bev? He's going to make you look like an idiot.
No chance, Roohif. You're the fucking idiot.
We'll see what he comes back with.
Dude,
Can you, hang on. To me, can you just explain what you mean by the angular distance between the Stadia heads? Just to me.
Just to you. Okay.
This is way above my head anyway. So just explain that bit because I'm not sure I understand what you mean.
Okay. There is a relationship between the angular size of something, so how big it appears from a perspective view. There's a relationship between that and the actual size of it and the distance. So, things get smaller in the distance, right? That's a mathematical relationship.
Okay.
So when you look through an auto level, there are some Stadia hairs, and you usually look through those and look at a grade rod, right, which has an actual size on it.
Yeah.
Right. So
and the
when you get
Stadia
the
hairs are on the lens, yeah.
Yes, yeah. So you have the actual size on the grade rod. You've got one part of that three-way equation. You need another part of the equation to work out the distance. All right, and that's when Bev says there's a 100-to-1 ratio. So you just multiply the actual size by 100 to get a distance. That 100-to-1 is basically another way of saying that there is a 10 milliradian angular distance between the Stadia hairs. That's how that relationship works.
Emma?
That's the second component that you need to work out the third.
Emma, can you ask
So
Roohif
there is 10
what would
milliradians between
happen?
the Stadia hairs, and that's how you can measure an angle with an auto level.
Ask Roohif what would happen if you took the diaphragm with the Stadia hairs out of one optics 32 times and put it into another optics 20
They're not
times.
ideal tools to use
What would
because they
happen?
can't rotate through the vertical axis. So you can't point it up to the sky, but you can still measure small angles plus or minus or above and below eye level.
Or ask him
That's
to
how the Stadia marks
unmute
work.
me.
The whole point is, though, this auto level isn't for measuring angles.
It's not an ideal tool, but it can be used for that, yes.
But why don't we stick to using it what it's actually supposed to be used for and use something that is...
Oh, why did I use an auto level?
Yeah,
it was $200 rather than a $1,000 theodolite. Like I will rent a theodolite rather than buy a theodolite.
It gives you one angle. It doesn't measure.
It does. Sorry, did you just say it gives you an angle?
No, I
Say
said
that again.
you
I think you did. It gives you
one
one angle.
Angle. It doesn't allow you to measure angles.
Then what are the Stadia marks? How far apart are the Stadia marks?
I don't know anything about it other than
Right, then shut the fuck up.
not adjustable. You cannot
If you said,
measure an angle.
you just said you don't know anything about it.
It gives you an angle.
Just said you don't know anything about it.
You tell me how you can measure an angle then if you've only got one fucking angle that you've got
The
in the
Stadia
sun.
marks. The crosshairs, the crosshairs are 0. The crosshairs are at 0. You've asked me to say something. Right? The crosshairs are at 0. The Stadia marks are plus and minus 5 milliradians. That's how you measure an angle.
Measure 1 degree.
1 degree? No.
Then it can't measure fucking angles, you lunatic.
Do angles less than a degree not exist or something?
Well, how would you know the difference between the angles if you can't differentiate them by the degree?
No, he said.
Could you answer that question though? But how would you know the difference?
He said,
okay,
listen.
No, but you're totally avoiding my point. Don't avoid it. If you're going to say that you're measuring an angle, then you can tell me the difference between 80 and 85. But if you can't do that,
not with
because hold on, I'm still talking. If you can't do that because your particular device can't differentiate individual degrees, then how do we know what you're measuring?
Brian said, can it measure an angle greater than a degree? And I said, no, 10 milliradians is less than a degree.
Okay, so you
measure
can't
angles.
Okay, how? So can you measure the difference between an angle of 88 and 89?
No, because it can't rotate between the vertical.
Okay, so you can't measure
axes.
angles. Congratulations.
Yes, it can. It can measure plus or minus 5 milliradians. It cannot rotate in the vertical axis, so it can't measure 88 to 89 degrees. It can measure plus or minus 5 milliradians from 0.
Measure what? Like, what? You've got an angle. Brilliant.
The horizon.
Okay, what do you... Yeah, and then what do you do?
So hang on, do we agree that it can measure the
No,
angle
go
of the
on.
horizon?
I'm just asking you, right? You've got your angle on a stick.
Not on a stick. You've got the angle through the auto level.
Okay, you've got an angle, right? Yeah?
Yep.
What?
Yep.
Go on. What do you do with that?
We compare it to the prediction for a globe and a flat Earth.
Go on. Like, so you go, I've just generated an angle from a device that isn't meant for doing angles, but hey, I've generated an angle.
But
then
it can.
You've got an angle. Yeah?
Right. Yeah.
And then
repeat back to me what I just told you.
You've got an angle.
Yeah, and what did I do with it?
You've just generated an angle out of your arse.
No, I've told you a dozen times what I've done with it, Bev. At least a dozen times.
No, you haven't. Like
Yes, I have.
You and Kosho both ran
it.
for about 3 hours on this topic. What the fuck do you do that you've just generated an angle from out of your arse? Right?
Not out of the arse, measured through the auto level.
Well, apart from the fact an auto level doesn't measure angles, right?
It can.
Well,
it can measure angles.
I know in your imagination you think it can, but now you are in possession of an imaginary angle, right? What do you do with that angle?
And what have I told you a dozen times what I do with that angle?
I don't know. You've got a big book somewhere that you can compare angles to, have you?
No, you know what I've done with it, Bev, because I hassled you for 2 days whether you could do the trigonometry to work out, to predict the angle down to the right.
Trigonometry? You've only got a fucking angle!
What is...
Not only has he only got an angle, you have to have something to have an angle from. What have you got the angle from?
From my observer location to the horizon.
What's pointing at the horizon? What?
The auto level.
So you've set a level line up to the horizon, yeah?
Yeah.
Which is an imaginary
measure the angle down to the horizon.
Which is an imaginary line. So you drew a line, and you drew an imaginary line to another imaginary line. So you drew an imaginary. Hang on. So there's an imaginary line going from your eyes to the imaginary line that is the horizon, and that's what you're using to measure the Earth. 2 imaginary lines. Congratulations.
I don't think the horizon is imaginary.
Okay, so you can go to the horizon. It's a physical place that you can go to.
The horizon has a physical place. Yes, it is water.
Okay, so you start walking.
Water.
Okay, if you start walking, do you get closer? If you're walking to the horizon, are you getting closer to it?
Your horizon will change.
No, you said it's a physical place. How is that changing? How does the physical place change, Roohif? How does it move?
If you're in one place and you're looking at the horizon, you are looking at water. Is that correct? Okay,
so then, no. If I'm looking at a particular, hold on. If I'm looking at a spot, that spot's not going to move, right?
That spot exists. It has a location.
Okay. But hold on. But you didn't answer my question. Will that spot move when I move?
That location will not change,
that's not answering the question. Will that spot move? Will that spot move? Just answer the question. Who cares what I'm trying to do? Will that spot, the spot you are calling the horizon, will it move when I move?
Your horizon is a function of your elevation.
Okay,
right?
so you're
But
just
when
going to
looking at the
avoid.
horizon,
Okay, just keep avoiding.
I
That's fine.
know what you're trying to say. I understand what
So,
you're trying to
well,
say.
Can we go back to what trigonometry you're doing with your angle?
Yeah, that was my first challenge to you. Can you predict an angle to the horizon given your elevation and the radius?
What? No. All you've got is an angle. That's it.
Yeah.
Yeah.
And what do I do with it?
I don't know. I keep asking you.
Yeah. we went through this for days, Bev.
No, I still
predict?
haven't got a clue what you can do with one angle. Right?
Yes. Okay.
Okay.
Right. If I know my elevation and I know the radius of the Earth, I can make a prediction
What?
as to what the
You've
angle...
just got an angle. Where's that other shit that you just generated? What the
We're
fuck?
in geometry now, Bev. We're in geometry. I can make
No,
a
you've
prediction
got
based...
an angle. That's all we've decided on, right? One angle.
Right, we've got an angle. We've measured an angle in the real world. Right?
No, you've generated an angle from your imagination. Okay.
Now we're going to compare it to a prediction made by a model, right? My model says that the Earth is 6,371 kilometers in radius. My elevation might be...
So this is
50 meters,
all
right?
of this other stuff you're doing now is the prediction from
geometry.
your model.
Yes.
Right.
I'm
So the
making a
only
prediction with my
tie to
model.
reality that we have is an angle that you've generated out of a tool that you don't get angles from, right? That's the
You do get
only
angles from
tie
it.
to
My model
reality
is making
that
a
we've got here
prediction.
now.
My model is making a prediction, all right? With geometry, I can make a prediction.
It's not
what
you
the
that's
angle
making
should
the
be to
prediction, it's your
horizon.
model that's doing that, is it?
Fine. My model is making a prediction to the horizon, the angle to the horizon. Can you do that mathematics?
Roohif, the horizon rises to your eye line.
It demonstrably does not.
Don't.
What angle have you got?
Bev's telling you to shut up because he knows you're
No,
wrong.
I'm just trying to say that I had you on that then, and now we've gone, right? Because you've
The
once
horizon does
again,
not rise to either.
all you have done is said that you have an angle, in reality, that you don't really have because you've just generated it from nowhere. But what you do with that angle, one angle, is compare it to something that your model predicts, and then once again you turn that back on me to get me to do the calculation for it. That doesn't
I'm
work,
happy to do it, 'cause I know
Roohif.
that
You're
you can't do it.
talking
Do you want to do it now?
shite.
Do you want me
What
to do
do
that
you
geometry?
do with your angle?
What have I said a dozen times now, Bev? What do I do with that angle?
You can compare it to something. That's all
To a what?
you've said.
Compare it to what? Compare it to what?
I don't know. Like something to do with your model.
A prediction made by my model.
Where is this prediction? Where do you compare it? Show me the thing that you are comparing an angle to. Because there's loads of angle. Well, there's not that many angles, really, is there? No, there isn't. So, let's say...
What's a prediction?
Yeah, like
how do you compare an angle to a prediction?
Yeah.
What is that?
It's great, isn't it?
If my model...
Yeah.
If my model makes... Say again?
Your model makes angular predictions.
Roohif, are you in the chat?
In the debate. I can
Debate
be in the
discussion.
chat, sure.
Right.
Yeah,
Brian,
what's in the
see
chat?
that channel. Brian, you can't see the live stream channel. You'll have to post it somewhere.
Is there something in the chat I should see?
Debate discussion, Bry.
Oh, you're in Let Off Steam or something?
No, so how does your model predict an angle? What exactly do you mean by that, Roohif?
If I know the radius and my elevation,
that your
I
model
can work out an angle to the horizon.
You know what your model is.
It's a radius of 6,371 and a given elevation.
Yeah, that's your model. Yes. So how do you compare that to an angle? Or how do you get that model of yours to predict the angle that you're just generating out of nowhere?
The geometry that you can't do.
I understand geometry. That's what I'm trying to get.
Yeah, then can you do that? This is the challenge I gave you a few weeks ago, and you just fucking dissembled.
I don't think you understand what geometry is, do you? You keep getting confused between trigonometry and geometry, and it's a lot of people get
part of geometry.
A lot of people get confused with that.
Do you not think that trigonometry is part of geometry?
Trigonometry is trigonometry. Geometry is geometry. The function of geometry is what gives rise to trigonometry.
Can you do the trigonometry, Bev?
It's not the geometry that we're talking about. Of course I can do trigonometry, right?
Okay, then predict an angle to the horizon on a globe.
Predict an angle? What the... This is what you are trying... This is all you've ever done, Roohif. When I've asked you what the fuck you do with an angle that you've just generated out of a device that doesn't do angles, you keep telling me to predict it for you. Right? Because you don't fucking understand what the fuck you're doing. It's embarrassing, Roohif. It must be really embarrassing for you.
I can draw it for you right now, Bev. Do you want to
go on then? Go on. Get the little whiteboard out.
Give me a minute, and I'll be back in a sec.
Brilliant.
Look in the chat. I've put.
He won't be back.
Looking at airplane windows. Every one of them, the horizon is at eye level.
You can't tell what eye level is, Bri. It looks like it is, but you don't know what eye level is.
He's gone.
Yeah, he'll be back. He's got to set his whiteboard up on his chair.
I went toe-to-toe with him over the dictionary thing, didn't I?
Yeah. Yeah.
He's trying to measure an imaginary area. Take an imaginary line that he's drawing. He's creating to the imaginary horizon.
Hello.
Can you get him to unmute me before he starts anything?
Yeah. Unmute domesticated primate, dude.
He's not here.
Yeah, he's not here.
Oh, I thought he was back.
No, also, sorry, I've got Eve here. That's why I haven't been able to jump in yet.
Honestly, I can't work out. I've done this with Kosho, done this with all of them, and this comes down to fucking Alberuni. This one angle that they have, I call it an angle on a stick, but he seemed quite keen to get rid of the stick, so he's just got an angle. There's nothing you can do with an angle within geometry. You need at least two. And this is the most vital part of it. Fucking right angle, triangle. He doesn't seem to understand what he's talking about.
Did you hear him say, then you calculate the known radius of the Earth? I thought that was what he was...
He's just predicting something. I don't know. It's really good. He gets an angle out of a device that doesn't measure angles, but he gets an angle, and then from that angle he says, my globe predicts you are correct angle. You are.
Can you just do me a favour?
Yeah.
Right, just as a matter of interest, because he won't unmute me. Can you ask him that question about swapping the diaphragms over in the optics of the auto level?
Yeah, I will do, but I'm not so sure he understands it, right?
Well, I just want to know if he understands the optics and whether he knows that they are specific for the focal length of each optic device. Because if he doesn't even understand that, then he doesn't understand how the optics of these devices work.
Here we go.
Sorry, couldn't find my little textures.
Can you do us a favour, Roohif? Can you just unmute DP? He's promised he's not going to call you a wanker or a tosser or anything like that.
There you go, DP.
There you go.
So who wants to do the trigonometry that Bev couldn't do?
Am I unmuted?
You are unmuted. Hey, DP.
Roohif.
Yes.
DP, you have to speak.
Right, I just wanted him to unmute me.
Okay.
Shall I ask him the question that I put to you earlier? Roohif, you know the stadia in the optics of a auto level. You have a 32 times optical device with a diaphragm with your stadia hairs on it, yeah?
Yeah.
What happens if you take that out of a 32 times optics scope and put it into a 20 times optics scope?
Oh, it'd probably be wrong, right? I assume.
I don't know. I'm asking you. What happens?
Oh, I think it'd be wrong.
You think it'd be wrong?
Yeah. It would no longer be 10 milliradians.
Why would that be?
Because it would be fixed to the focal length of the auto level.
Right. Okay. Well, you claimed earlier that there was adjustable focus on these devices.
Yeah, not adjustable zoom. Not adjustable magnification.
So it's not adjustable focus then?
Zoom is different to focus.
So can you focus these optical devices or not?
You ready to do some trig?
Can you focus these optical devices or not, Roohif?
Yes, you can.
You claim you can.
It doesn't change the zoom. It doesn't change the magnification.
Hang on, why are we doing trigonometry?
This is the challenge I gave Bev a couple of weeks ago, and he couldn't do it.
But why are we doing trigonometry?
This is how to predict the angle to the horizon on a globe.
Oh, okay. Thank you for
How do you
clarifying.
know the angle before you can predict it?
Say again?
How do you know what angle you're looking for?
We're going to calculate this one. This is the angle that you measure on the... Oh, fuck, that's going to be a theta.
None of this even works.
It won't work.
No. I just thought look, man, I'm just trying to figure out how these lights work first before I do anything. I need to know how these lights work. So I have my left and my right.
Hot mic, Rob.
Here. No problem.
Is
I
it?
have the diagram for
Yeah.
these.
Hot mic, Rob.
You want to know how these work?
Well, yeah.
Okay.
So that, yes. So
Go to here.
yeah, I just didn't know
Hang
which
on,
one
when I
to
can
mute.
get my phone there, I'll mute him.
Yay! Roohif's got his little board out again.
His little baby whiteboard.
I think that's so cute. I'm thinking
It's
about
got its own
going
chair.
Yeah, I'm going to go out and get myself one, I think.
You ready?
Its own chair. It's got its own high chair.
Yeah,
No
sorry,
expense. No expense.
You ready, Bev?
Yeah.
Yeah.
The horizon always comes up to eye level.
Yeah,
for a
it
start
doesn't,
off, so
Brian.
your drawing's completely wrong.
It demonstrably
Yes, it
does
does.
not. No, it doesn't. This is
Yes,
the whole
it
thing. The
demonstrably does. I've just put 4 pictures. I have just put 4 pictures out of plain windows that show
Have a look.
the horizon perfectly level with eye level. So
How
change
are you?
image and where
How are you getting eye level?
straight line across your horizon.
What are you using? What are you using,
You're not
Brian? What are you using to get eye level in these photos?
the level of the eye, believe it or not.
How are you measuring it? Like how are these not just pointed slightly down?
Eye level means eye level.
Yeah, how are you measuring it?
Create that angle down to your stupid, ludicrous ball earth horizon. There is no such thing. The horizon rises to eye level. So
What device are you using? What device are you using to give you eye level in these photographs?
An eye.
Yeah, how accurate is your eye?
A lot more accurate than yours.
What do you mean by level, Roohif?
Have you ever seen?
What do you mean by
Rory,
level,
the guy that
Roohif?
lived in where was he? Off in the island somewhere. Remember Rory? Rory had this little experiment, and like you stand on the other side of a room and you look at a point on the other side of the room that you think is eye level. Keep your eyes on that point, and then you walk towards it and you get close to it and you see how accurate your eyes are. And he was off by miles. Your eyes are not accurate in the same way that an auto level is accurate. Do you think an auto level would give you a more accurate eye level or a less accurate eye level than your eye?
On a plane?
you have to look through the auto level?
Sure.
Are you looking through the auto level with your eyes? Okay, so your eyes. So your eyes, which you just said aren't good, are what you're using to get your level. Congratulations.
No, the crosshairs will hit something, and that's your eye level.
The crosshairs.
Can we get on with the demonstration,
you're looking.
please?
Yeah, you guys do the demonstration. Look at a point.
He's already got a curved Earth for a start off, so it's
Yeah, we're making a prediction with a model. My model is a curved Earth. Is that okay? Are we going to do this or not? Oh, yes, absolutely. Let's do it with a flat Earth.
Change your picture to a flat Earth.
Yeah, we'll do that after this. This is to predict an angle down to the horizon on a globe.
But there is no down to the horizon. Horizons come up to your eye level.
They demonstrably do not, measurably do not.
Brian, what you're doing is completely wrong.
Measurably, they do not, Brian. Measurably.
Measurably, they fucking do.
No, Bri.
Anyway, yeah, let's do this. Right, so this is our little dude with his auto level, and he is some height above the Earth. Right?
Is that your stick then? H is we'll call that stick.
Sure, that's my observer with his auto level here. So his auto level points horizontal.
Yep.
Right, we're measuring the angle down to the horizon. So this is a tangent. Yep. And we're measuring this angle here.
That's a straight line, right? Is it? Because I mean,
this one.
Yeah, we went over to Gems the other day, and they had the circle as the horizontal, but you don't. You have the tangent is the horizontal, is it? Or no, the horizontal is up there.
No, this is looking down to the horizon. That's your tangent down to the horizon.
Okay, so that other one's your horizontal.
This one.
Okay, yeah. Okay, right,
All
I've got
so
that.
This angle, so your vertical and your horizontal, what is this total angle?
What is...
Is this a right angle, is what I'm asking. Is that a right angle there?
Would that be a vertical and a horizontal?
Yes, so it's a right angle.
Perpendicular, 90 degrees, yeah.
All right, if this angle's theta, what angle is that?
It would be 90 minus...
I have to write like an idiot here. Hold on. 90 minus theta.
To write like an idiot.
Well, I'm writing like that anyway.
No,
so this angle is 90 minus theta.
I don't go for that. People who write are not idiots. That's not the view of On the Level. So,
I'm writing awkwardly. Okay. All right, so that angle is 90 minus theta. We agree. This angle, because this is a tangent, that is a right angle. Do you agree?
Wow. Okay.
Yes.
Yeah.
Yep. Okay. So
at the point of intersection, is that what you're saying?
Yes.
Right. Okay.
That's a tangent. Yes.
Okay. And then,
so
but
that's 90 minus theta.
Let's not get into the pure geometry of this, right? Because you are going to be equating this to a model, are you? Right.
This is what we're doing. We're predicting an angle.
Right. So that big curved line there, right? Is that a globe model?
Yes, it is.
Okay.
It is a globe model, yes. Well done.
Right, so when you assume you are looking down at a tangent, right? Because, I mean, most people say that the horizontal's a tangent. That's really weird. But, okay, so you're drawing a line that isn't a horizontal tangent. It's just a tangent, right?
It's a tangent from our auto level to the horizon. Yep.
Okay.
Cool. So if that is 90 minus theta, and that is a right angle, what angle is that?
Similar triangles, right?
What angle is it?
Well, wouldn't it be theta?
Yes, well done.
Wow.
Theta.
You know what? You know how I know that?
Because
because triangles always have 180 degrees in them.
Euclidean
fantastic,
yes.
That isn't it?
Euclidean triangles do, yes.
Oh no, just triangles, right?
Well, a non-Euclidean triangle
What's one of
more than
them?
180 degrees.
What's that?
Oh, let's do this.
Good.
Right.
No,
now,
yeah, I was saying, like, but you are using, just to show that you are definitely using Euclidean mathematics to do this.
Yes, I am. Yes, I am. Okay. Right, this is all two-dimensional right now. Right?
Well, it's just geometry, because you're assuming that's a sphere.
No, we're just doing circle geometry, 2D plane.
Yeah, but you are equating it to your model, right? Your model isn't
cross-section of a sphere.
Your model isn't a two-dimensional plane like that, is it?
Yeah, we're getting there, Bev. We'll get there eventually.
Can we just confirm that your model isn't, because you seem to be conflating this with a model, but this isn't a model, is it?
This represents the globe model, yes.
Within Euclidean geometry, right?
Yes.
Okay, so you're definitely not using non-Euclidean geometry, are you?
No, we're not here. This is plain Euclidean geometry, two-dimensional flat plane cross-section of a sphere. We're not doing like spherical excess on a triangle or anything, right? This is plain 2D geometry, Euclidean geometry.
Spherical excess of a triangle?
Yeah, which can be measured, by the way. People measure it with theodolites.
People can... What? People can measure spherical excess.
Let's get this done. Let's get this done.
Go on. Yeah, all right.
Let's get it done. All right, so we agree that angle's theta?
Yeah. Hey,
what is
this looks a lot like, what's he called? Al.
Al Baruni, probably.
Yeah. Fight the Flat Earth did a thing of this. I'll put it up.
What is this distance, Bev?
What is it? I don't know.
What is that distance?
I don't know. Give it a R.
Radius.
Yeah, well, if that's a circle, then yeah. That's what you call radius, yeah.
All right, so you know Sokotoa? I'll go to right there.
Ooh, bit of trig as well, eh?
Sokotoa.
Yeah.
All right. If we're working out this angle, which sides do we have?
What?
Which sides of this right angle triangle, if we're trying to work out this angle, which sides do we have? This is basic trig, Bev.
You have all of them, don't you?
I don't know this one. How long's that one?
Oh, is that what you're measuring?
You don't have the R either.
Is that the idea?
What?
Is that what we're doing here?
We're doing trigonometry.
Yeah, I know, but I'm saying for the function of this, what the purpose is to find out what that distance is up there.
No, we're trying to find theta.
What do you mean? Trying to find theta?
We want to measure this angle here, right?
You're measuring that out of you've generated it out of an auto level, haven't you? Yeah?
We'll get there eventually, Beth.
So what are you doing? Are you checking it? Or what? Like I'm saying, what are you doing?
Which sides of this triangle do we know the length of?
I don't know. Like
you've
got R and H.
Yeah, so that's one side. Which side is what's the O and the H stand for?
Oh, fuck's sake! Like, do you not know? It's the hypotenuse and the opposite and the adjacent.
Excellent, very good. Okay, what side is this relative to that angle?
Dude, this isn't like child playground sort of shit. That's right.
Then you should answer them like this, right?
Like, dude, are you
what
trying
side
to?
is this?
Are you trying? God, are you trying to teach us here? And what is it that you are trying to teach us exactly?
The formula for this angle.
You've just measured that. That is the measured angle. What the fuck are you doing?
We're making a prediction based on the globe model.
Is this prediction geometry?
This is just geometry.
Right.
What is the formula for that angle?
Right. You know when people go out in reality, like, and measure angles, right? You know what they do with them? They plot them and then they use them, right? They don't then go off to find a model to predict the angle that they've just fucking measured.
Which side is this of the triangle?
Oh, for fuck's sake. It's R. Look, you've just drawn it. It's got R wrote on it.
Yeah, the length is R.
Right, okay.
But is it the opposite? Is it the hypotenuse? Is it the adjacent?
Dude, you've measured an angle. You haven't actually measured an angle. You've just generated an angle. And now all of this, right? All of this that you're doing now is to predict the angle.
Is this the adjacent? Is it the opposite? Is it the hypotenuse? Not difficult question, Bev. Really not a difficult question.
You do it yourself.
You've already got your angle.
It's the adjacent, isn't it?
It's the adjacent.
Yeah.
Very good. That's our adjacent.
Prick.
We got this one. What's
That's
that one?
R, isn't it? And H.
Yeah. What side of the triangle is it in this?
Oh, for fuck's sake. Do you not know? It's the side opposite the right angle. It's the fucking hypotenuse.
Excellent.
The longest side of the triangle is always opposite the largest angle.
Excellent. So we've got the adjacent and the hypotenuse. Which one of these do we use?
We've got the hypotenuse. You've got that H up there as well, have you?
Yeah. Which one do we use?
Go on.
We use cosine, right? Yep. We use cosine, correct?
Go on. Carry on.
Yeah, right. We agree that we use cosine?
Oh, God. Does he want confirmation on every step of the way?
Yeah.
Well, I don't think Bev knows this basic
Well,
shit.
no, this is basic,
Roohif.
right?
Just
All you're
fucking
doing
get on
here
with
is
it.
fucking giving all of the numbers and
But you couldn't do
everybody's
this
giving
2
you.
weeks ago. You couldn't do this 2 weeks ago, Bev.
So far, you've not got fuck all other than a drawing of some basic shit that everybody knows.
So
right.
cosine
Now
theta equals...
now we're going to get into the interesting shit.
Yep.
Let's go.
Right. Cos theta equals what?
What's
the adjacent?
You're projecting
R
an angle, aren't you?
Over. R over what?
Go on.
R plus H. Do you agree?
R plus H. Very good.
So you know the radius.
Yeah, so do you know the radius or the angle? Which is
My
the
model,
one that you
my
do
model
know?
says the radius is 6371.
Ah, so you've just generated that number.
Pulled that out your ass.
Right.
That's fine. My model doesn't have to have any justification.
Right,
What
can
we
you-
get to,
can
what
you
we're
see-
getting
doesn't
to,
need to justify his model.
what we are getting to is if my model makes accurate predictions, if my model, I'm going to say this, if my model makes accurate predictions, it is more likely to be true.
Can
Do
you
you guys
see?
agree with that?
Can you actually see there, everybody, when just looking at that now? What the reality bit that Roohif's got? He's got a height and an angle up at the top, the very top of the picture. Now, you see all the rest of that shit that he just drew, and then did some trigonometrical mathematics because he drew a right-angled triangle there. If you get rid of that right-angled triangle and pretend it's not there, he's got an angle on a stick and nothing. The rest of it, he's just used similar triangles to place the angle within a right-angled triangle that he's completely fabricated around some numbers that he's just fabricated into the mathematics to predict the angle that he's got up at the top.
Do you agree that's the formula for this angle?
Not that angle. It's the formula for the angle in the middle of the triangle. What the fuck's that angle there? Look at it. How's that angle the same? It's a similar.
How is this angle the same as that angle?
Yeah.
We agree that this is 90.
Yeah.
Right? Yeah. So this angle is 90 minus theta.
Yeah.
And therefore this is theta.
Why?
So these are the same.
Oh, it's only because you've got that other right angled triangle there. Right?
Yeah. Do you disagree that's not 90? What's that?
I disagree with all of that shit that you've drawn at the bottom half. It's a magic
you don't
trick.
think a tangent. You don't think a tangent forms
Can
a
you
90
not
degree
see
angle?
the magic trick that you're just trying to perform on us here?
Sorry,
or do you
Piss.
not even realise it's a magic trick, Roohif?
You disagree with that?
He doesn't even realise.
He doesn't even know, yeah.
Yeah, he's
You disagree with that?
His angle on
Yeah,
the
you're
stick,
just
and he's
sort of
he's just
generating all of
Hang on,
that,
hang on.
Roohif.
Why is there a bend there?
What bend?
A bend where?
DP, shut up. The bend.
Like bend where? This is your auto level, looking horizontal. This is your sight line to the horizon.
Have a look in debate discussion pictures from Ayers Rock, on top of Ayers Rock, where the horizon
Nicely done, Emma.
Yeah, and again, how are you measuring eye level? How do I know that you're not just pointing down by half a degree or something?
Look in debate.
Well, it depends what you.
Yeah, I see them.
What's
and the
level?
The question is, how do I know that you're not just looking down a little bit? How are you measuring eye level? The question doesn't change.
You're looking down a lot.
Oh, this is generally not a lot. It's like usually less than half a degree. But it's measurable. It's not 0.
Well, that looks more than half a degree to me.
Oh, it's a fucking diagram, Brian.
What?
This is a diagram.
Yeah, he's just generated that whole circle and that triangle there from nothing, right? All he's got is an angle on a stick.
Do you
You've got to
disagree
do some
that
fantastic methods.
Yes, I do disagree. It's
Okay, what's the problem with the trig?
complete and utter fucking nonsense. Sorry.
As expected from you, Brian. As expected.
Where did you get the right angle triangle from?
Pumped it into your brain. You're trying to pump it into ours. It is complete and utter nonsense.
Where did you get the R value?
He pulled it out.
This is just geometry. This is just geometry. I can call this fucking X if you like. This is a circle.
Where'd you get the R value?
I don't have to give you an R value. The R value is in the equation. I don't have to put a number in there.
It's in the equation.
This is doing geometry.
As long as he generates a circle.
Who disagrees with this? Who disagrees with the geometry?
Completely. It's all bullshit, mate.
Yeah, substance, Brian. Substance, champ.
From your vertical down is a lot greater than half a degree, isn't it? If that is a parallel line at the top.
I don't know what this is.
That's the angle that you generated, Roohif.
What dotted line? That's parallel, is it?
Hang on. You're yelling too much and maxing out your microphone, Brian.
It's just ludicrous, mate. And I don't know
I know.
You're an intelligent guy, and they've pickled your brain.
I know that you can't handle the math, Brian. I understand that you can't handle the math.
Don't do that, Roohif.
It's not the math. It's the reality. The reality of it is nonsense.
Does anyone disagree with the math? Bev, do you disagree that that formula is correct?
That's just a mathematical formula, right? Because you've generated a right-angled triangle at the bottom. What, 90% of your drawing there is all imaginary, Roohif.
I don't care whether you think it's imaginary, Bev. I want to know whether you think this formula is correct based on this diagram.
Yeah, it's
is there
just
anything
pure
wrong with
maths.
the geometry?
Roohif,
Good, okay.
of a right-angled triangle. It's just a right-angled triangle.
Yeah. Hang on, where's my wipes? Fuck. Hang on. So we all agree that's correct, right? The geometry is correct.
That's not geometry, Roohif.
What do you mean it's not geometry?
It's got cos in it.
Oh, trigonometry, whatever.
Yeah. They're not the same thing, Roohif.
Fine. Trigonometry. Do you agree that's correct?
You've just done it. It's simple.
Good.
Roohif.
Okay. So, if I have a dude here with an auto level at height H...
No, you've got a guy stood on a fucking ball, haven't you?
Yeah.
Well, nobody would get an auto level and stand on top of a ball.
I did.
If you keep walking straight, you're going to fall down the goddamn ball.
Oh, Jesus.
That'd be good to watch that. Somebody set up an auto level on a ball.
Yeah. This is where I wonder whether you guys are...
How are you stabilizing the ball? Like, wouldn't it be
yeah, what are you putting the ball on? A flat surface?
Jesus. Anyway, we're going to do a flat plane.
Could we do this on a humpback bridge?
Are we doing a flat plane now?
Yes, we're doing a flat plane. Let's talk common sense. With the horizon that rises
No, you're
to
still
your eye line.
no, you're still in the same problem. You've only got an angle on a stick, and you can't do anything with an angle on a stick.
We just made a prediction to what the angle should be if we have a radius and an elevation.
Well, I just predicted you'd fall down the hill. You'd go rolling, tumbling down, just like if you took a.
I have to assume that you're a Poe then. Have to assume you're trolling in a Poe. You can't be that stupid, honestly.
Oh my God, you're so. It's crazy. I can't even believe you even think this is reality.
All right, flat plane.
Believe you me, they have been convinced. I'm sure they're all hypnotized into this shit. They must be, because these are people, they're knowledgeable people. Yet they fucking believe every word they say.
What do you get
Brian,
paid?
Take a chill pill, Brian.
Mate, I feel for you. If you think this is fucking reality, I really do feel for you.
Yeah. All right. Question: on a flat Earth, where is the horizon?
Oh.
At eye line.
So here.
Bry.
So the angle to the horizon is 0. Done.
No, Bry.
Right.
Don't.
Beth's telling you to shut up.
Do
Brian.
not do this, Bry. No. Oh, fucking hell.
Oh dear. All right.
It's
So
not.
0, right? Brian says it's 0. We go and measure it. It's not 0. Therefore, not flat Earth.
I will take the responsibility for this. Carry on, 0. Now,
0.
Now show me
Right.
I live on a fucking ball.
Go and measure the angle to the horizon. It's not 0.
It's 0. It comes to the eye of the observer.
No, it doesn't. Go and measure it with an auto level. It's not.
Yes, it does. You can't measure it with an auto level. A level sets a level.
What about with a theodolite? We point at the horizon.
I haven't got one.
I can probably hire one. I'm not going to buy. Actually, Critical Think said he's going to buy one. So
Come on, carry on.
maybe he can do that.
Let's do it my
No,
way.
we're finished. We're finished. We're finished. 0.
0.
Yep.
Yeah, 0. Now
Right.
prove that I live on a ball.
All right. My model makes a more accurate prediction than yours. Therefore, mine is more likely to be true than yours.
To what? To the ludicrous fucking assumption you live on a ball? Ludicrous
Like I said,
assumption you live on a fucking 1,000-mile-an-hour spinning ball. Is that what you're saying?
If my model makes accurate predictions and is not falsified, if my model makes accurate predictions that are not falsified, if my model makes accurate predictions that are not falsified, then my model is more likely to reflect reality.
Your model has curved water.
And?
Impossible.
Says a flat earth as well, so that- And again, I'll just post the. And again, I will just point to the MC footage of the Conti Leon boat with no distortion due to mirages, missing 13 meters, and the base of the Conti Leon appearing, or implied base of the Conti Leon, being below the ship in the foreground.
It's all optic bullshit.
Oh, yeah, of course we can't use optical anything. This
No,
is
man.
where Flat Earth has just gone ridiculous. We can't use optical anything.
No, you can't.
Anyway,
'Cause it destroys.
this is your prediction: 0 degrees on a flat Earth. Go and measure it in reality.
Yeah, this is not Bev's. Bev's not taking that.
I know he's not.
0 degrees to the horizon, which is not a physical place because it moves when you move.
That doesn't mean it's not a physical place. Two people can have different horizons. They're still physical places.
No, it's not a physical place because when
It
you
is a
go there,
physical
it's
place.
not there.
What are you looking at? Are you looking at water, or what are you looking at? You're looking at water. That water exists. That water exists in a location. It's a physical place. The horizon is physical.
It is an apparent position where the sky meets either the ground or the sea. Apparent.
Are you looking at water? Are you looking at water?
What have you drawn? Doesn't matter, does it?
Are you looking at water when you look at the horizon? Is it water? Yes. Yes, it is. Does that water exist?
Necessarily. You go
Does it
back
exist?
down after
Does the water exist? Yes. Does it exist in a location? Yes. It's a physical thing.
Yes,
that's different.
A bit like your train tracks. Is it a physical position where the train tracks meet?
No, because they don't meet.
Exactly, you fucking idiot. Nor does the sky and the fucking sea.
The horizon is the last physical point that you can see. It is water. It exists in a location. Another person will have a different horizon.
It is not a physical position.
Is it water? I go back to the same question. Is it water?
Are the rails metal?
Yes.
Do they move together?
No.
Then you're a cunt.
You're right. You're muted, Brian. See ya. All right, we all done here? Brian says it's 0. He can go off and measure it in reality and see that it's not 0.
Can I just ask you what you do with a guy goes up there, up the mountain, measures an angle. What's he do with that?
Compares it to that both predictions by models.
What both
predictions? Brian's prediction was 0. Brian.
No, sorry.
Brian's prediction.
No, that's not Brian's prediction.
Yeah, it is.
That's all you've got to go for, really. Just Brian's prediction, and then whatever
Brian's flat Earth prediction.
Your other one.
Brian's flat Earth prediction was 0. 0. His prediction was 0 on a flat Earth.
Right, but we know that when we go out there, we measure an angle, right?
H.
That's
my prediction.
What?
That's my prediction for the angle.
Can I say something
Flat Earth prediction
real
0?
Quick? No, I'm not going to say 0. Can I just say something real quick?
Yeah.
Okay. The horizon will always be about 5 feet 7 inches below my eye line at any height.
Just wrong.
Do you understand that? Do you understand that?
I understand that you assume a flat Earth.
No, listen. My eyes are about 5 feet 7 inches off the ground. So 100 miles away, the horizon will be 5 foot 7 inches off the ground.
On a flat Earth, I agree that would be the case.
No.
But we're not on a flat
No
Earth,
matter
and this angle is not 0.
Do you understand what I said?
I understand that you assume you're on a flat Earth, and you're wrong. So, whatever.
Shouldn't your ball horizon be going down?
It does. The higher you get, the further down it is.
Can I just have a go here, Roohif?
Are you sure about that?
Yes.
Can I have a go here, right, Roohif? Because I know, right, that there is a level of the ground underneath me, and then as I rise, as in elevation, I rise vertically, I am a distance away from where I was, right? We call it elevation. Yeah?
Yeah. Yep.
Right, okay, so elevation is a difference. Now, because the elevation at floor level, sea level, I am an elevation above that sea level, I know that level, sea level, will never rise to my level because it's plane parallel, right? That's the way elevation's measured.
Yeah, but it will approach it.
Right, okay, so I know that there will always be an angle drop from horizontal to the horizon. Right, now, but the horizon is an apparent position. It's not a physical place. It's not an actual place.
Position. Again,
it's not.
What are you looking at? Are you looking at water?
But
does that water
all
exist?
I have
in a location?
Is a angular measurement device at the top of the hill. So that man at the top of that hill there, right, will measure an angle. So there will be an angle. I know
in reality,
there will be an angle measured. Right. Now, what do we do with that angle?
Okay, and that question is, what is your prediction for that angle on a flat Earth model?
I don't have a prediction. I just measure an angle. I don't predict
I have a prediction.
a distance. That when I'm going to measure a distance, I don't predict it first. I just measure it, right?
Sure.
And that's all I do is deal with stuff in reality. Now, I'm gone up a hill and I've measured an angle. What do I do with that angle, please?
If you are trying to describe reality, you need a model or a concept or an idea in your head. All right?
I've just been and measured an angle.
Yeah.
Roohif.
Okay.
Yeah.
And what's your prediction if the Earth is flat?
Look, the Earth isn't flat because I'm at an elevation. That means I am a vertical height above something, which means, guess what,
Is your
Roohif?
sea level datum flat
It's
or not?
not flat.
Is your sea level datum flat?
Oh, you mean the ordnance datum is a vertical datum? Yes.
So is sea level flat?
It's a vertical datum, the ordnance datum. Roohif.
Yeah. Does it flat?
What do you mean? Is it flat? It's a datum.
Is it flat?
It's,
but is a sea level
It's a datum.
curved?
The vertical distances are measured, and we call that a change in vertical. We call that elevation change, don't we?
Right. And if you have 3 points that are all 0 meters above sea level, right?
Yep.
Does that plane coincide with the surface?
3 coplanar points. 3 coplanar points. Yeah, of course they are.
Rolling eyes here, Bev.
It is. It's 3 coplanar points.
And does that plane coincide with the surface of the ocean?
Yeah, plane.
Yes,
yeah.
Okay. So you're a flat earther. Okay, you're a flat earther. Very good.
No, I'm not a flat earther. I've just explained
You
to you. You've got a guy up on top of a mountain there.
The plane. You just agree that your datum is flat.
Yeah, it is.
Yeah,
it's
okay,
a
so you're a
vertical.
flat earther.
It's a vertical change. Is a change in elevation, right? That's how we measure.
Yeah.
Right.
Come on,
you know what tool we use to measure that vertical change in elevation?
What would you use, Bev?
A level. Right. So that establishes a horizontal plane of reference, doesn't it?
It does.
Right.
It does.
So if we measure a vertical change from a horizontal plane, guess what that makes our datum?
No, it doesn't. No, it doesn't.
Of course it does.
No, it doesn't.
Yeah. Horizontal.
If your datum is curved.
No, that's not horizontal.
If your datum
level is
curved,
horizontal, right? That's not level. Is it?
If your datum is curved and you stick your instrument in the middle, you will get accurate differential level.
So which is level there then, Roohif? Which is level?
Here.
Yeah.
That's level. That's horizontal.
Oh, that straight one, the horizontal one.
Yeah, this is an auto level. It's not a water level.
So mean sea level is your datum.
Yep.
Yeah. That would be parallel to the... No. There's obviously a difference in the vertical height there, isn't there?
From this datum, if you're here...
You've got that auto level. I mean, look at the difference in height. From where the auto level is and that bit there. What?
If you stick an auto level here, that's your level. That's
no,
your
you've got... Look at where your little dotted lines meet that.
Yeah. That's what happens on a
That's
globe,
a change
and
in
that's what happens
elevation, right? It's a change in the vertical.
Oh, question for Brian again.
What do you mean question for Brian? No,
Brian's posted
stick
more
on
shit
this,
in the chat.
Roohif. This is elevation.
Yeah, Bev, I know you know that the globe, that this is what happens. We went through this days
ago.
No,
look at the picture you've got there, right?
Yeah.
Where is your change in elevation, please, on that thing?
Between here and here, there isn't.
Look at the line at the side of it.
This is down, that's down.
Yeah, but look where you would put a rod that measures that. See that little dotted line? Right, the auto level. Yeah. Put a rod at the end of that and tell me whether it's difference in elevation. Yeah. Put a rod there and put a rod like a meter away from it. Put right in the middle.
Then you're introducing curvature. That's not how you do differential leveling.
It's elevation change, dude.
No, this is not how you do it.
It's not how you do what?
To get an accurate elevation from A to B, you stick your instrument in the middle.
No, you don't.
Yes, you do.
No, you don't. You do transitions.
Yeah, this is your backside, and this is your foresight. Whatever the difference is here, regardless of the shape of this, is accurate.
No, that'd be like one. You don't just do one sighting. You to keep going. You keep going and going and going. Yeah?
Do another one, sure.
What?
Then you go from B to C. This is down.
Oh, what? Them horizontals look like they're intersecting. Roohif.
You're just dicking around now.
What are you doing?
Yeah, the fact that you said that, I'm blown away that you're in this conversation.
It's reality, dude.
What?
Do you not understand what a globe entails?
I understand what you're trying to say on a ball, but that's not reality.
So you do, okay.
I walk downhill with my water level. All the water would pour out of it.
Do you understand this is a globe and therefore this is down?
Sure, you have.
Okay, so what you said was fucking stupid, right?
You're saying that a person is going to walk on that and walk down.
No, this is not down. This is not down.
It is.
This is down. No, it's not.
In reality, it is.
No, it's not. This is the center. This is down. Do you not understand how a globe works? This is like seriously basic level stuff.
I know what you think would happen if you were...
Okay, so you're not walking down. If you know what I think, then this is not walking down, right?
Okay, but you can't walk... Okay, I'm sorry. It's just, you can't do it. You're not Spider-Man. You're not an ant. You can't walk on the side of things.
You agree this is not walking down on a globe?
On a globe, you would be...
On a globe.
Walking down it.
Excellent. Not walking down on a globe. Very good.
When you say globe, you realize it's the globe model. Right? Not globe reality, globe model, innit?
If my model makes predictions that match reality, I am more confident that my model reflects reality.
Right, so you think is it it's your model that's making that prediction that you're drawing there, isn't it? Right? Do you think that
intersecting horizontals happen in reality?
Do they?
Yeah, they shoot over each other.
How do you have if you have horizontals parallel to the horizon, how do you...
Horizontals parallel to the horizon? I disagree.
Oh, right, okay. So you don't think a horizontal is parallel to that of the plane of the horizon?
Again, I've told you a dozen times, Bev. Horizon is curved.
Okay, so the horizontal straight line has no relation to the horizon, to you.
The horizontal plane is not parallel to the horizon.
Okay, I mean, that's a very bold claim, but I mean, I guess that's needed in order to have horizontals intersecting with each other, right?
Yeah, these shoot over each other. This is your down from this point. That's your horizontal at this point.
Yeah, where do those...
That's your horizontal.
Where do the horizontals intersect?
Somewhere here. But
somewhere.
they shoot over each other, right?
Do you know of any devices that we have where we can measure the angular deviance of horizontal towards the horizontal that it's intersecting with?
Sorry, is there a device that measures vertical angles?
A vertical angle, isn't it? Yeah.
These lines shoot over each other, demonstrably in reality.
Oh, wow. Dude, that's a big word.
Demonstrably?
Yeah.
Okay.
Well, you can show that horizontal lines intersect.
by virtue that they shoot over each other, yes.
Wow. That's a pretty bold claim, right?
Yeah, I've demonstrated this. You do reciprocal shots with an auto level, they shoot over each other.
That's not demonstration. That's not demonstration.
What do you mean? That they shoot over each other does not imply that they intersect? Of course it does.
Well, I would imagine it should be quite easy to demonstrate with them.
Oh, hang on, Beth. Let me just say this. Drawing a picture is not a demonstration.
Yeah, I've done this demonstration in reality. They shoot over each other.
Okay, can we should be able to use a water level, right?
Drawing
No,
a
because
picture
water levels
does
do not
not
give you horizontal.
demonstration.
Water levels do not give you horizontal.
They don't establish even altitude.
They do give you an even altitude, yes.
Oh, but you
They
wouldn't
do
call
not
that
establish a horizontal.
You wouldn't call that a horizontal condition, then, would you not?
No.
Hmm.
Because the datum is curved.
Right.
Simple stuff, Bev. All right, I'm going to have some brekkie. Any further questions?
He's a fucking ballet. I think they've changed their
All right,
you know,
good.
Bev.
Yeah,
Flat
yeah.
Earth prediction 0. Globe prediction that this matches reality. The end.
Oh, right. Okay. Yeah, man. Well, yeah.
That does not match reality.
Measurably does. Go and measure it.
Yeah, it's all optic crap.
No, we don't.
Yeah, okay. So we can't use any optical instrument.
Demonstrably, I think.
photos.
Yeah, I remember you saying.
If you kept digging layers of the earth off, and you kept digging and shrinking it down to the size that's manageable, that you could see a curve. Are you telling me you think we're going to be standing sideways and upside down on a ball?
Yes. Do you know why?
Your eyes won't do that. Turn your head to the left or to the right. You know you're leaning. You know you're tilted. You're in fantasy land.
All right.
Okay, if you think that's true, then get a very large ball, go stand on top of it, and walk off the side of it. Because that's what you're doing. It's the exact same thing. If we took a layer of earth,
you can't be serious, dude.
A layer of earth off.
You really can't be serious. Anyway, I'm going to have some brekkie. Catch you guys later.
Don't come back.
Sorry, guys. My father passed away, and I'm a little upset. So.
Okay, no worries. Sorry about that, dude. All right. Catch you guys later. Yeah.
Sorry to hear that, Euclid.
Thanks.
Oh. Right, is he gone?
Thanks.
Like water. Now you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put in a teapot, it becomes the teapot. Now water can flow, or it can crash. Be water, my friend. Be water, my friend. Now you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put in a teapot, it becomes the teapot. Now water can flow, or it can crash. Be water, my friend, water. Like water. Now you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put in a teapot, it becomes the teapot. Now water can flow, or it can crash.
Can an auto level be used to measure angles?
According to Engineer Supply, an auto level cannot measure vertical angles and has limited accuracy in measuring horizontal angles.